Good morning, everyone. Today we are going to discuss about electronic devices and circuits, unit 1. Okay. So in our last classes we are discussed about our digital electronic subject, but in today's class we are going to discuss about our electronic devices and circuit. So while coming to this, so what is the name of this subject? Electronic devices and circuits. So those devices are works based on the principle of electrons movement is called electronic devices. Okay. See here while coming to the first topic here, the classification of amplifiers. What is the first topic? Classification of amplifiers. So before going to explain you about classification of amplifiers, first I would like to explain you about amplifier. Define amplifier or what is meant by amplifier. So see here the amplifiers or the devices are used to do the process of amplification. So what is meant by amplification? The property of increasing the strength of weak signal is called what? Amplification. So what is meant by amplification? Increasing the strength of weak signal is called amplification. The device which is used the property of amplification is called amplifier. So simply amplifier is a device which is used to increase the strength of weak signal. And while coming to the classification, the amplifiers are classified into two types based on the coupling. So based on the coupling, the amplifiers are classified into RC coupled amplifier and a transformer coupled amplifier. So what is meant by coupling here means connecting the output of first stage to the input of next stage is called coupling. So coupling means simply connecting, but here connecting the output of one stage to the input of next stage is called what? Coupling. So coupling means here connecting the output of previous stage to the input of next stage. So here if to connect the output of first stage to the next stage, we are using here resistors and capacitors, then the coupling is called what? RC coupling. And the amplifier used with this kind of coupling, that means to connect the output of one stage to the input of the next stage through the resistor and capacitor, then the amplifier is called RC coupled amplifier. Okay. And while coming to the next one, that is transformer coupled amplifier. In transformer coupled amplifier, the output of one stage is connected to the input of next stage through the transformers. So see here, this is one amplifier. The output of this amplifier is connected to the next stage through the transformer. So if any amplifier used the transformer at its outputs to connect the output to the next stage is called transformer coupled amplifier. And while coming to the next one, amplifiers are classified according to the frequency. So according to the frequency, amplifiers are classified into two types: audio frequency amplifiers, radio frequency amplifiers. And while coming to the audio frequency, these amplifiers are used to amplify the signals in 20 Hz to the range of frequency of the signals is 20 Hz to 20 kilohertz. So what is the range of the signals? 20 Hz to 20 kilohertz. So audio frequency amplifiers are the amplifiers are used to increase the strength of the signals. Okay. And so which signals will be amplified the audio frequency? Only the signals are in the range of audible. So what is the audible range? 20 Hz to 20 kilohertz. And see here, next one is radio frequency amplifiers. So these are the amplifiers are used to increase the strength of the weak signals, and those frequency of those signals is about 20 kilohertz. Okay. So based on frequency of two types, audio frequency amplifiers, radio frequency amplifiers. Audio frequency amplifiers are able to amplify the signals having the frequency in the range of 20 Hz to 20 kHz. And radio frequency amplifiers are the amplifiers are used to increase the strength of the radio frequency signals, that means about 20 kilohertz signals. Is it clear? And while coming to the next classification, see here. Based on primary function. Okay, see here, based on primary function, again the amplifiers are classified into three types. Okay, voltage amplifier, current amplifier, power amplifier. So while coming to here, voltage amplifier means these are the amplifiers are used to increase the strength of voltage signal. These are the amplifiers are used to increase the strength of voltage signal. So next one is what? Current amplifier. Okay, next one is current amplifiers. So it is an amplifier. It is used to increase the strength of current signal. So next one is power amplifier. Power amplifiers are the amplifiers are used to increase the strength of power signals only. So finally, according to the function, the amplifiers are classified into three types: voltage amplifier, current amplifier, power amplifier. Voltage amplifiers are used to increase the strength of voltage signal. Current amplifiers are used to increase the strength of current signal. Power amplifiers are used to increase the level of power signal. Okay. And the next one, based on the number of stages, also the amplifiers are classified. So while coming to the number of stages, if only one stage is there, that is called single stage amplifier. Like this, only one transistor is there to amplify the strength of the weak signal. So then that is called single stage amplifier. More than one stages are connected in cascade form, means connecting the output of one stage to the input of next stage. So then that amplifier is called what? Multi-stage amplifier. Then that amplifier is called what? Multi-stage amplifier. Okay. So in this way, the amplifiers are also classified on the number of stages. And see here, while coming to the next one, based on the ground connection. Okay. Based on the ground connection, also the amplifiers are classified of three types. So basically the amplifier is a device that is made from the transistor and additional circuits. But here amplifying element is only the transistor. Amplifying element is only the transistor. The transistor is used to increase the strength of peak signal in total amplifier. So the amplifiers are available in how many number of configuration? Three configurations. What are the three configurations? Common emitter configuration, okay, and common base configuration, common collector configuration. And what is meant by common emitter configuration? If the input is connected in between emitter and base, and the output is accepted from collector and emitter. Now here the emitter is common now. Input is applied in between emitter and base. Output is collected from emitter and collector. So then this amplifier is called common emitter amplifier. Is it clear? This amplifier is called common emitter. And this terminal is connected to ground. Input is connected to the base with respective of emitter terminal, and the output is collected from the collector with respect to of emitter terminal, and this emitter terminal is connected to ground, so that it is called common emitter amplifier. And next one is what? Common base amplifier. Next one is what? Common base amplifier. So while coming to the common base amplifier, here the base terminal is common. Okay, base terminal is common. For emitter terminal, here we are applying the input, and from the collector terminal we are accepting the output. But while applying the input across the emitter terminal, okay, the input is applied at emitter terminal with respective of base terminal, and output is collected from the collector terminal with respective of base terminal, and finally collector terminal is connected to ground. So this is called what? Common base amplifier. Next one is what? Common collector amplifier. So common collector amplifier means collector is connected to ground. Collector is connected to ground, and at base we are going to apply the input, and across emitter we collect the output. If this configuration is called common collector. So among three configurations, the common terminal is connected to ground. If emitter is common for both input and output, emitter is connected to ground. If base is common for both input and output, base is connected to ground. If collector is common, collector is connected to ground. So based on their grounded configuration, the amplifiers are classified into three types. If emitter is common, the amplifier is called common emitter amplifier. If base is common here, the amplifier is called common base amplifier. If collector is common, the name of the amplifier is called common collector amplifier. And see here, while coming to this, based on magnitude of input also, the amplifiers are classified into two types. What are the two types? Small signal amplifiers and large signal amplifiers. Okay, small signal amplifiers and large signal amplifiers. Here small signal amplifiers means if it is used to increase the level of small range of the signals, small amplitudes, then that is called small signal amplifier. If these amplifiers are used to increase the large amplitudes, then that is called large signal amplifier. Is it clear? Next one, so need of multi-stage amplifier. What is next one? Need of multi-stage amplifier. While coming to the need, in most of the applications, the current gain or the voltage gain obtained from a single transistor is not sufficient. What is the need of multi-stage? Why we are connecting one amplifier to the other amplifier means whatever the output we are getting from the single stage, that is not sufficient to drive the load or to drive the output. Okay, hence two or more signal stages of amplifications are frequently used to achieve the desired amplification. Is it clear? So in most of the applications, the current gain or the voltage gain obtained from the single transistor is not sufficient, not enough. But in two or more single stages of amplifications are frequently used to achieve the desired amplification, maximum amplification. Such amplifiers are called what? Multi-stage amplifiers. Means what? Simply connecting the output of one stage to the input of next stage and output of next to the input of third and so on. In this way, if we will connect the output of one stage to the next and so on, these amplifiers are called multi-stage amplifiers. Okay. And in multi-stage amplifiers, the output of one stage is fed as the input to the next stage. This connection is called what? Cascading connection. Okay, what is the name of that connection? If we connect the output of one stage to the input of next stage, cascading connection. So in this way, the amplifiers are connected one to the next one. So the connection name is called what? Cascading. Is it clear? And while coming to the next one, see here, a practical amplifier is a multi-stage amplifier. Why? Because single amplifier never give us the sufficient output to drive the load. So maximum all amplifiers connecting the output of one stage to the input of next stage. And to isolate or to connect the output of one stage to the next stage, here we are using coupling element, whether it may be resistor or capacitor or transformer, or sometimes the output is directly connected to the inputs. Is it clear? Sometimes it is directly connected to the input. And see here, while coming to the block diagram of multi-stage transistor amplifier. Okay, once observe the diagram. How many number of stages are there here? In multi-stage transistor amplifier, three stages are there. What are the three stages? Once see. This is the first stage and this is the second stage and this is the third stage. How many number of stages are there here? Three stages are there. First stage, second stage, third stage. And see here, to connect the output of this first stage to the input of next stage, here one block is used. What is the name of that block? Coupling. And connecting the second stage output to the third stage, again we are using one stage, that is called also coupling. So in this way, the output of an amplifier is connected to the input of next amplifier through the resistor or capacitor or transformer. So this is called what? Cascading connection. And in this way, the amplifiers are connected one to other. Then the amplifier is called multi-stage transistor amplifier. Is it clear? And multi-stage amplifier, number of single stage amplifiers are connected together. That is called what? Multi-stage transistor amplifier. Okay, and see here, while coming to the next one, in multi-stage amplifier we are using two or more single stages. Those are common emitter amplifier. Then that is called cascaded connection. In multi-stage amplifier, first stage is CE and second stage is CB. Then that is called what? Cascaded amplifier. Okay, in multi-stage amplifier, if two or more single stages are used, the two are CE amplifiers. Then that is called what? Cascaded amplifiers. And in multi-stage amplifier, if CE is at first stage, means common emitter amplifier is used at first stage and a common base amplifier is used at second stage, then that connection is called cascaded connection. See here. So in this it is all are common emitter, then that is cascaded. In cascaded, CE, this is CE, is connected to CB, common base. It is base, it is emitter. Here collector is connected to emitter. So this connection is called cascaded connection. Okay. And while coming to the next one, the characteristics of amplifier. The amplifiers having the following characteristics. First one is gain. Next one is frequency response. Third one is bandwidth of the multi-stage amplifier. And see here, while coming to the gain, for any device having gain, so gain is defined as the ratio of output to the input. Gain is defined as the ratio of output to the input, like this. So here the gain is defined as the ratio of output to the input for any general circuit. Here also the gain is defined as the ratio of output voltage to the input voltage or output current to the input current is called what? Gain. And here the gain of multi-stage amplifier is defined as the in any transistor if number of amplifiers are connected, okay, in multi-stage amplifiers. So the overall gain is equal to the product of gains of individual stages. Product of gains of individual stages. So see here how it should be came from diagram. One see. For example, if any amplifier consisting of two stages here, this is having gain 1, this is having gain 2. So the total gain G is equal to G1, G2. But in generally the gain of amplifiers is indicated with A1, A2, A3. So that overall gain is equal to product of gains of all individual stages. Product of gains of all individual stages. So see here. Now this is the frequency response of multi-stage amplifier. How can we consider? Once we the frequency response means the curve that must be drawn between the voltage gain and the frequency of an amplifier is called frequency response. Okay, what is meant by gain of multi-stage amplifier? The gain of multi-stage amplifier is the product of gain of individual stages. Now next one is frequency response. What is meant by frequency response? The frequency response means that is the curve that must be drawn between the voltage gain and signal frequency of an amplifier is called what? Frequency response. A higher or upper 3 dB frequency of end stage amplifier is given by, means here frequency is referred as upper 3 dB frequency, lower 3 dB frequency, like that. So see here, for n number of stages multi-stage amplifier, so F is the initial frequency. If number of stages are n, then 2 to the power of F to the power of n is called what? Frequency of n stages. And see here, if here 1f is the lower initial frequency, 1f dash is the lower initial frequency of n stages, where here n is what? N number of stages. Okay, so in this way, what is meant by frequency? The curve that must be drawn between the voltage and frequency is called what? Frequency response. What is meant by gain? The gain of multi-stage amplifier is the product of gains of individual stages. And what is meant by frequency response? The curve that must be drawn between the frequency and amplitude, voltage amplitude, is called what? Frequency response. And what is meant by bandwidth? So it is defined as the range of frequency over which, it is one particular range over which the gain of amplifier is equal or greater than 70.7% of its maximum gain. 1C bandwidth means, for example, this is the frequency and amplitude gain. So here it is the amplitude percentage. For example, here we are achieving 70%. If we are getting the range of frequency over which the gain is equal to 70%. From which range to which range? 5 to 10 Hz or 10 to 20 Hz. From which to which the gain is equal to 70%. So that range of frequencies, in which range the gain is equal to 70%. The range of frequencies are called bandwidth. Is it clear? The bandwidth is defined as the range of frequency over which the gain of an amplifier is equal or greater than 70.7% of its maximum gain. Okay, the bandwidth is defined as the range of frequency over which the gain of an amplifier is equal or greater than 70.7% of its maximum gain, and it is known as bandwidth. Is it clear? So what is meant by gain of multi-stage amplifier? So the gain of multi-stage amplifier is defined as the gain of products of individual stages. And next, frequency response means the curve that must be drawn between the frequency and gain is called frequency response. And bandwidth means it is defined as the range of frequency over which the gain of amplifier is equal or greater than 70.7% of its maximum gain is known as bandwidth. And the bandwidth of single stage amplifier is given by, see here the formula, 70.7 percentage. Okay, and see here next topic is two stage RC coupled amplifier. What is our next topic? Two stage RC coupled amplifier. The name itself indicates complete construction. How many number of stages are here in our circuit? Two stages. And which type of coupling is used here? RC coupling. Okay. So now we are able to draw the circuit now without seeing the circuit also. Two stage RC coupled amplifier. Because of that, how many number of stages are there here? Two stages are there. And which coupling elements are used here? RC coupling elements are used here. Means with the help of R and C elements, the output of one stage is connected to the input of next stage. Output of one stage is connected to the input of next stage. So how many number of amplifier stages are there? Two. So the output of one stage is connected to the input of next stage. So in this way, the two-stage RC coupled amplifier is formed. Here what is meant by coupling? Connecting the output of one stage to the input of next stage is called what? Coupling. Okay. And see here. So here under the construction, two transistors are there. How many number of transistors are there? Two transistors are there. So this is first one and this is second one. And each and every transistor having two resistors R1 and R2. Okay. What is the purpose of these two resistors here? These two resistors are used for providing the biasing. What is the use of these two resistors? These two resistors are used to provide the proper biasing. So what is meant by biasing? To make the emitter base junction is in forward bias condition and collector base junction is in reverse bias condition. Then the transistors are in active region. So then this is called means biasing. What is meant by biasing? Provide the emitter base in forward bias condition, collector base is reverse bias condition, such that the transistor works under the active region is called what? Biasing. And it also makes the operating points independent of the temperature variations. Operating point is independent of the temperature variations. Okay, if the operating point is depends on the temperature variation, automatically the leakage currents will be increased and the self destruction of the transistor is occurred. So here, to protect the transistors from that, the resistors R1 and R2 are used. It is the main theme of these two resistors. These resistors are used to provide the proper biasing. What is meant by proper biasing? By making emitter base junction is in forward bias condition, collector base junction is in reverse bias condition, such that the transistor works under active region. The transistor works under active region. If the transistor works under active region, the operating point is independent of the temperature variations and other parameters, leakage currents like that. If it depends on those parameters, automatically the leakage currents will be increased, the self-destruction of the device is occurred. So, to protect the transistor from the self-destruction, here we are using the resistors R1 and R2 across each transistor. And the next one is RE and CE. These two resistor and capacitor parallel combination. Okay, resistor is connected in parallel with the capacitor. These two, resistor and capacitor, connected in parallel are connected across emitter terminal. And these are connected providing the bypassing to the grounded signal. Okay, so emitter bypass capacitor. If any excessive voltages are there, they must be bypassed through the capacitor. Okay, and while coming to the next one, here one more capacitor is there, C in, and this is CC, and this is CCO. So first one is what? C in. So first one is C in. So here the name of this capacitor is called input coupling capacitor. Input coupling capacitor. Here what is the function of this capacitor? This capacitor is used to connect this input signal to the base of the transistor. So what is the main theme of input capacitor? It used to connect the input signal to the base of the transistor, and it will provide or it will allow only the AC signal and it block the DC signal. This coupling capacitor CN will allow only the AC signal and it will block the DC signal, and it will also provide segregation or isolation between the base of transistor and input signal. So due to this, if any excessive voltages are there, then only the capacitor is affected. It will not affect the transistor. Okay, so these are the functions of input capacitor. What is the main function of capacitor C in? It is used to connect the output of, means the last stage, that is input, to the C in capacitor. The name itself indicates C in means input coupling capacitor is used to couple the input to the base of the first stage transistor, and it will also block the DC signals and allow only AC signal. And next one, this will also isolate the base of the first stage transistor from the input AC signal. Okay, and while coming to the next stage, here CC is there. So this is the coupling capacitor. Here second stage output is connected, means this is the first stage. First stage output is connected to the input of second stage through this coupling capacitor. Output of this transistor is connected to the input of next stage through this capacitor. The name of this capacitor is called coupling capacitor. The name of this capacitor is called what? Coupling capacitor. It will connect the output of first stage to the input of next stage. And see here, more one capacitor is there here, C or C out. Here this capacitor is used to connect the output of last stage to the load, or we will collect the outputs from the last stage through this capacitor only. Okay, it will provide or it will protect the next stage load from the surplus or SAR. Okay, and these are the different capacitors used in the amplifiers. How many number of capacitors are there in the amplifier? 3 are there: capacitor coupling, capacitor input, and capacitor output. So input capacitor, coupling capacitor, output capacitor. Input capacitor is used to connect the output of one stage to the input of next stage. Simply the last stage output, that is input signal, to the base of the transistor 1. And the coupling capacitor is used to connect the output of first stage to the input of next stage. And the output capacitor is used to collect the outputs through this capacitor only. And here the resistors R1 and R2 are used for providing proper biasing. Biasing means to make emitter base junction of transistor is in forward bias condition, and collector base junction is in emitter base, collector base. Emitter base is in forward bias condition, collector base in reverse bias condition. Then the transistor works in active region. It makes the operating point is independent of temperature variations. Then it will protect the amplifier from self-destruction. That means thermal runaway. Okay, so this is the construction of two-stage RC coupled amplifier. And while coming to the operation, see here, in operation, if the input signal is applied across the signal, so which must be given to the transistor. Cause of transistor is a semiconductor device. Without giving input signal also, due to temperature variations, small amount of current will be or voltage will be produced across the transistor. Okay, and here after application of this input signal, the voltage or current occurred due to the temperature is merged with the input signal, so that it will increase the strength of input signal. And this signal will provide 180 degrees phase shift to the input signal. For example, if the input signal we are applying here is positive and negative, whatever the output we are getting here, it is negative and positive. So how much phase shift it will provide? 180 degrees. Positive is converted into negative, negative is converted into positive. This is the main character of the transistor. Transistor will provide the 180 degree phase shift to the given input signal. And the signal developed across the collector of the transistor T1 is given to the base of the transistor T2 through the coupling capacitor CC. Okay, next again this increased strength signal is given to the transistor T2 and the output will be produced. Is it clear? And see, next while coming to the operation, once see the slide, whatever already explained, that is there in the slide. It consists of two single stage RC coupled amplifiers. In there it consisting of resistors R1 and R2 to provide what? Biasing. Already I said it, biasing and stabilization circuits. Okay, and while coming to the next one, see here the emitter bypass capacitor offers low reactance path to the amplified AC signal. And see in the next one, working. Whatever I explained, that is only there in working. When an AC signal is given to the base of the first stage transistor, the amplified signal will be developed across its collector, okay, of the first stage. And this amplified signal developed across the resistor R and C1 is given to the base of the next stage through the coupling capacitor CC. Okay, and see, while coming to the next one, it will allows only the AC signal, it will block the DC signal. Which one? Input capacitor or coupling capacitor. So thus the DC biasing of the next stage is not disturbed. That's why the coupling capacitor is also called blocking capacitor. All the coupling capacitor, whether it may be input coupling or it may be output coupling or it may be middle stage coupling, All are allows only the AC signal but block the DC signal. And the second stage further amplifies the signal and appears across the capacitor resistor of the second stage. In this way, the cascade stages amplify the signal and the overall gain is considerably increases. Okay. And while coming to the advantages, see here, it requires no expensive or bulky components. What are the components in single stage RC coupled amplifier? Only resistors are there, capacitors and transistors. Every component having very less cost, so that it becomes economical, also lightweight. And its overall amplification is higher than that of other couplings. Its overall amplification is more than that of other couplings, and the frequency response is excellent. Okay, and see here, it has minimum possible non-linear distortion because it does not use any coils or transformers which might pick up undesirable signals. It has minimum possible non-linear distortions because it does not use any coils or any induction coils or transformers. If any coils or transformers are there in circuit, they may be pick the undesirable signals. Hence, there are no magnetic fields to interfere with the signal. Okay, and while coming to the next one, disadvantages of RC coupled amplifier. See here, only two disadvantages are there. First one is poor impedance matching and low voltage and power gain. So here, if one output from this is connected to the next stage, the impedance matching is very low. And these two stage RC coupled amplifiers are used for only low voltage and low power gains. These are used for low voltage and low power gains. Okay, and see here, so which topics we are discussed today? So in today's class we are discussed about classification of amplifiers and also what is meant by multi-stage amplifier, what is the need of multi-stage amplifier, and what is the construction of RC coupled amplifier. Okay, while coming to the first one, classification, mainly the amplifiers are classified into two types. What are the two types? Based on coupling, RC coupled amplifier, transformer coupled amplifier. If the resistors and capacitors are used to connect the output of one stage to the next stage, then that is called RC coupled amplifier. If the transformers are used to connect the output of one stage to the next stage, then the amplifier is called transformer coupled amplifier. If no elements are used to connect the output of one stage to the next stage, then that is called direct couple. So finally, according to the coupling, these are two transformer and RC coupled. If no element is there, that is called direct couple. And according to the signal also, these are three types: current amplifiers, voltage amplifiers, power amplifiers. So according to the signal is to be amplified, the amplifiers are classified into three types: current amplifier, voltage amplifier, power amplifiers. And while coming to the next one, according to the signal also, the amplifiers are classified into small signals as well as large signals. Small signal amplifiers as well as large signal amplifiers. And according to the frequency also, they are classified: audio frequency amplifier, video frequency amplifier. So what is meant by audio frequency amplifier? The audio frequency amplifiers are the amplifiers are used to increase the strength of weak signals in the range of audible 20 to 20 kHz signals only amplified. And in video frequency or radio frequency, about 20 kHz signals can be amplified. And while coming to the next topic, multi-stage amplifiers. Multi-stage amplifiers means the output of one stage is connected to the input of next stage. So in the multi-stage amplifiers, how can we define the gain? The gain of multi-stage amplifier is defined as the product of gains of the individual stages. So, and it is mathematically expressed as overall gain A is equal to product of individual gains A1, A2 up to AN. This is the gain of the multi-stage amplifier. And while coming to the frequency response, it is the graph that must be drawn between the frequency and the amplitude of the amplifier, then that is called frequency response. And while coming to the bandwidth, so it is defined as the range of the frequencies. They must be reached at 70.7% of its maximum voltage, 70.7% of its maximum amplitude, then that is called what? Bandwidth. So main three parameters are there for multi-stage amplifiers: gain, frequency response, bandwidth. So gain is defined as the product of the gains of individual stages, and frequency response is defined as the curve that must be drawn between the frequency and gain amplitude, and bandwidth is defined as the range of frequencies at that moment they reach the gain. 70.7% of its maximum gain is called bandwidth. So these are the different parameters relevant to the gain. Okay, and while coming to the next one, what is meant by two-stage RC coupled amplifier? So in two-stage RC coupled amplifier, how many number of stages are there? 2. So what are the coupling elements? Resistor and capacitor. So how they are connected? In cascade fashion. Output of one is connected to input of next stage. How many number of transistors are there in two stage? 2 transistors. How many number of capacitors are there? 3. Input capacitor, coupling capacitor, output capacitor. What is the function of coupling capacitor? Allow only the AC signal and block the DC signal. That's why these capacitors are also called blocking capacitors. These capacitors are also called blocking capacitors. And while coming to the next function, these will provide the function of isolating the output of one stage to the next stage. And the resistor network R1 and R2 will provide proper biasing and network. And the next one is CE emitter bypass capacitor will provide the low reactance path to the amplification signal. Okay, so now I would like to conclude the class.